for further analysis of Argyria and what it constitutes, Argyria is an electrical problem in which, if we take, for example, any of the silver salts, silver chloride, we could have chosen silver sulfate, silver nitrate, silver acetate. Any of these traditional salts of silver run the risk of losing silver's interest, so to speak, when they're dissolved in solution. Because silver's a heavy metal, it's not exactly sodium or potassium. Kind of like along the lines of calcium. Calcium doesn't want to stay in solution very readily, but it's a heavy metal, though. For calcium to come out of solution, you're left with lime deposits. You're left with seashells. They take the calcium out of the water and they form a shell around themselves. Calcium carbonate. But with silver, it doesn't work that way. The silver comes out of solution, becomes a metal, and when that happens, the acid component is left behind. So I'm reviewing what I've said before because I want to add something to it. The acid component, let's say it's the chloride ion, is left behind, and it's an acid, but is electrically not paired anymore with a buffer. Namely, the silver was acting as a buffer, just like a sodium ion, a buffering agent, an alkalizing agent. So the chloride ion is left there being acidic all by itself and wants to give its charge. You can't give it to the silver because the silver came out of solution, so the silver is not available anymore. Even though it's around in the neighborhood, it's a particle of silver, and it's not the same as an ion. So the chloride ion wants to share its charge with an opposite charge, an opposite charged ion. And since it can't deal with the silver, it gives it to the flesh. And that's why it burns the flesh. Now it's transferred its charge to the flesh, and now this particle of silver can see and appreciate that charge transferred from the chloride ion to the flesh in the form of burning the flesh. And now it wants to unite with the opposite charge, and it's mobile. The burnt flesh is not. It's stuck where it is because it's a structure. It's part of the structure of the physiology. So the silver can now migrate itself over to the burnt flesh and embed itself because it wants to. It wants to unite with it. It's no different than ions in solution. They're opposites. Opposite charges attract. Electrical charges, when they're opposite, they attract. So they like to hang out together. Just like when you have an anode and a cathode, the silver comes off the anode and moves towards the cathode because it wants to be with it. It wants to be with its opposite charge, to balance it, to electrically balance itself. So Argyria is a desirable condition of particles of silver in the physiology. They want to unite with a charge that's opposite to themselves to feel satisfied, to feel whole, to feel completed. And wouldn't you know it, they find burnt flesh that has the opposite charge to themselves imparted by the chloride or the nitrate ion or the sulfate ion or the acetate ion due to the fact that they lost that. The acid lost its interest and the silver came out of solution, so they couldn't negotiate anymore, a relationship. They didn't have a relationship anymore. Yet they demanded one. They wanted one in order to keep things electrically neutral. So now their electrical interaction is not as a solute is what goes. Water is the solute, right? So no, it's the solvent. Water is the solvent. So the ions of silver and the ion of chloride were the solute, S-O-L-U-T-E, the solute. Had been prior to losing their charges when they were dissolved in the solvent of water within the physiology, the body fluids. And the first thing to come out was the silver because it's very unstable, because it's a heavy metal. And the chloride's not far behind. But to do so, the chloride has to burn flesh. To give up its charge. And then the silver, as a particle, can unite with that burnt flesh to neutralize its charge. So that's the way to look at Argyria completely. I I just thought the silver just kind of fell into the burnt flesh. No, it's attracted. It's electrically attracted to it. That's why it ends up there. Hello? That's why it goes there. It's attracted to it.